Okay, so today we're going to look at Notes 18, Rules of Exponents, Part 1. First of all, when we're dealing with exponents, let's go ahead and talk about what that means. If you have a b squared, what that actually means is that there were two b's that were multiplied together. Likewise, if you have a b times a b times a b, you have b to the third. The exponent tells you the number of times that that number was multiplied. So 4 b's being multiplied together would give you a b to the fourth, etc. Excuse me. Now on these first ones, they want us to expand it out and try to come up with the rules before we introduce the rules. So let's do that. If I had an x squared, that means that there are two x's. And I'm going to multiply those two x's that are being multiplied together by 3 x's that are being multiplied together. So if we're following the same idea as above, we would have x to the 5 because now there are 5 x's that are being multiplied together. To get there, I'm noticing that I could actually just add the 2 and the 3 together. And that's actually going to become our like base rule, I think they call it a power rule. I call it like base. If you're multiplying 2 x's together, you want to add the exponents. Excuse me. For this next one, if I had 6 x's on the top of our quotient, and you have 2 x's on the bottom of our quotient, with fractions, we're allowed to reduce one factor on the top with one factor on the bottom that are like. And in this case, there are 2 of them. But you're still going to be left with x to the 4th on the top, or x to the 4th over 1, which we know, of course, we'll just write as x to the 4th. So a neat rule that we need on this one is that the 6 minus 2 would get us that 4. So when you have like bases, 2 base x's that are being multiplied together, you want to add the exponents. If there's a quotient, you want to subtract the larger minus the smaller exponent, but you want to subtract. And wherever the larger one is, that's where you leave your final result. And finally, this last one, now I call this one my power problem. So this one I like to refer to as a like base problem. This is a quotient, and this one I'm going to call a power problem because you have something raised to a power raised to another power. Now let me explain. If I have x to the 3rd raised to the 2nd power, it means I have 2 of these, doesn't it? That's what this exponent is saying to us. But if I expand each one of those out and multiply them all together, we get x to the 6th. So the rule that we're going to come up with is if you have a power problem, that means something to a power raised to another power, we're going to multiply the exponents. Okay? Now let's look at the rules, and again, they call them something a little differently than I do, and that's okay. You do what your instructor instructs you to do. For me, if I have 2 like bases that are being multiplied together, I know I'm going to add the exponents. So I like to call the power rule like bases. And so on this example, a to the 5th times a to the 4th would end up being a to the 9th. Quotient rule. Here's what we're talking about now. If you have a quotient where you have the like base on the top and one of those like bases on the bottom, but there are exponents in play, you always want to subtract the exponents. So you would get c to the 5 minus 1, which would be c to the 4th. And I know that the c to the 4th goes on the top because 5 is definitely a lot larger than 1. Now for our power rule, and I like to explain this one this way. If you have something raised to a power and that is raised to another power, you want to multiply the exponents. So you're going to get, like in this example, y to the 4th raised to the 5th power. That is a power problem to me, and that is where you multiply the exponents. So you'd get y to the 20th. mix those in instead of putting dots. All right. Now, we've seen this when we were taking square roots of fractions or, yeah, it's mostly been with fractions if you raise to a power. If you're raising multiple variables to a power, you just do it to each one. Don't overthink it. So if I had an a to the 1, b to the 1, which is actually what you have, you can raise each one of those to the n power, but then they become power problems, don't they? It's something to a power raised to another power, so you multiply. 1 times n is going to give me the n, and then 1 times n on the b is going to become an n power there. Let's do it with our example. If we have 3 to the 2nd power, and then we have an x to the 1 raised to the 2nd power, we have 3 squared, which is 9, and power raised to a power, you multiply the exponents, you get 9x squared is your answer. For the power of a quotient rule, same thing. And honestly, when you have a 1, it's always going to just look like you're just attaching the n to it. But that's actually what's happening. You have something to a power raised to a power, so they're being multiplied. But if you get comfortable enough with it and understand that it works that way, you can put the exponent on it. Now on this one, it's going to be the x that gets raised to the 2nd power and a 4 that gets raised to the 2nd power. That's going to give me x squared, and 4 squared is going to be a 16. And there you have it. Now, let's go ahead and look at some examples. If we have, excuse me, if you have 4 squared times 4, well, just a plain 4 actually has an exponent of 1. So if we wanted to use our rules, these are like bases, aren't they? If you're multiplying 2 4s together that happen to have exponents, I know that like bases, we add the exponent. So it's going to be 4 to the 3rd power. Well, 4 to the 3rd power is 4 times 4 times 4. And I'll let you do the arithmetic at the side there, but that actually ends up being 64. So it'll depend on how your instructor wants the answer. If they want you to leave it with exponents, you would stop right here. I'm going to ask you to carry it all the way through. On number 2, your like base this time is a negative 2. And because you're multiplying 2 like bases, you're going to add the exponents. 2 plus 3 is 5. So if you are allowed to leave it there, you do. You're finished. But for me, I want you to go ahead and multiply them out because you know how. And when you do that, you're going to end up with a negative 32. One, negative because there are 5 of them, right? And every pair of them become positive. Still going to be 1 negative left over. And the 32 from multiplying 5 2's together. Number 3 is also another like base problem. C to the 6 times c squared is going to be c to the, let's see, like bases, we add the exponents. So we get c to the 8th. On number 4, the only part I want to really point out here is that when you have a plain x, a plain y, a plain t, whatever it is, it's actually got a little exponent of 1. So if you have 3 y's that are being multiplied together, there's still just a like base problem. Like bases, we add the exponents. So 3 plus 1 plus 5 is 9. On number 5, we're going to multiply the like parts together. We have the constant part of it. So the 3 times negative 5 is going to be negative 15. We have x squared times x to the 6th. And that's actually a like base problem as well, isn't it? But when you multiply 2 x's together, you add the exponents. So you have x to the 8th. You take care of the numbers exactly the way you've always taken care of multiplying numbers together. The x's, the variables now, are what we're dealing with, and those are our like base or power problems or quotient rules that we learned today. When I'm multiplying 3 pieces together, I don't see any exponents on the outside of the parentheses, so I'm just going to take care of the like parts. 3 times 4 times 2 is 24. Then I'll take care of the A's. I've got 1A, 3 A's, and 1 more A that are being multiplied together. Because they're like bases, I add their exponents, and that's how we get A to the 5th. For the B's, we have B squared, a B, which is B to the 1, another B, which is B to the 1, for a total of B to the 4th when you add the exponents. And C. C to the 1 times C squared times another C to the 1. That's going to give us C to the 4th power. This next one is actually a quotient rule. The larger exponent is on the top, so I'm going to leave him where he's at, right? The answer will be left on the top, and this is going to be 7 minus 5, which is 3 squared. Now, if it throws you off a little bit, to remind yourself, you can make yourself a little rule, right? You're going to do 7 threes on the top, and then 5 of them on the bottom. Now, I wouldn't want to do this with really large exponents, but if you forget, you can always do this and say, oh yeah, there's going to be 2 of them left on the top. And of course, I want you to clean it up. So the answer there will be 9. Now let's use our quotient rule. I have 8 x's on the top, 4 on the bottom. That's going to leave 4 x's on the top. For the y's, I have 3 y's on the top, 1 y on the bottom. Subtract, and there will be 2 y's left on the top. I drew the line in case we had some left over on the bottom. We didn't, so that's it. Let's look at now, and again, stop the video and try some of these on your own if you'd like to. 10 divided by 2 is going to be 5. You don't change the way you handle numbers, okay? M to the 5th over M to the 3rd. The larger one's on the top, so I'm going to subtract and keep the answer on the top. 5 minus 3 is going to be 2, so I've got 2 M's left on the top. For the N's, also the N that is larger is on the top, so I'm going to subtract the exponents. 10 minus 4 is 6, so we get N to the 6th. For the next one, that's a power rule, isn't it? B squared raised to the 5th power. We're going to multiply the exponents, so we're going to end up with B to the 10th. Same thing on number 11. Stop the video if you'd like and try it. You're going to end up with W to the 3rd raised to the 6th power. It's a power problem, so we multiply the exponents. That is W to the 18th power. And number 12, I have a negative 3 raised to the 2nd power. That's raised to the 2nd power. Power problem, a power raised to a power. So it's actually negative 3 to the 4th power. And when I clean that up, I will end up getting 81, positive 81. I'll see you in the next video, and we'll finish up section 18.